Morning. Today we are doing our last objective of this unit. Excuse me, Miss Madison, I've started. So we're doing our last objective, so that means tomorrow we're going to be reviewing our unit. So next Friday will be, Wednesday we have our sports snelling field trip, so no math on Thursday. Sorry. Tomorrow's Wednesday, we will review. Thursday is our field trip. Friday, we will do retake. When we come back next week, after Memorial Day on Tuesday, will be our practice test. Next week, Wednesday, will be the real test. Okay, so we need to stay on top of our math work, knowing that we are testing. Real test is next Wednesday. So our last objective says I can compare theoretical probability and experimental probability. So we need to know what those two things mean. If it's theoretical probability, that's what, it's going to take a minute for it to write. Maybe, hopefully, is it going to pop up for me? That is the question. So what should happen? So our theoretical probability is what should be happening when we do something. So we say, oh, we spin that spinner. What is the probability it's going to land on the green? 1 out of 4. That's what should happen. Is that what happens all the time? 1 out of 2 chance of landing on heads when we flip our coin? Is it always going to be I flip a heads, I flip a tails, I flip a heads, I flip a tails, I flip a heads, I flip a tails? Is that what we always get? No. Your experimental probability is what actually happens. It doesn't always follow that theoretical probability. So experimentally we get differing results. Okay. So we are going to do some experiments in class. We are going to be, so if you are watching this at home or you're watching this elsewhere, you are going to need a coin. You are going to need a dice. We're going to be talking about what will happen theoretically and what we actually get. So I have coins and dice in my room for us to use in here. So if you are somewhere else and you don't have a coin or a dice, make sure you check one out from me so you can do your work. When we look at flipping a coin, we can fill stuff in together theoretically, because this is what we've been talking about. So let's look at our first experiment, flipping a coin. Theoretically, if you flip a coin 10 times, how many times should you get heads? Ava? 5, right? It's half and half. 5 heads, 5 tails. How many students are in math class today? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So we have 18 students in class today. If each of you flips a coin 10 times, how many total flips would that be? Cameron? If we have 18 students, and each one flips a coin 10 times, what math do I have to do to find that? Shh, oh, too many voices. Marina? Shh. I need to multiply. So what 2 numbers should I multiply, Marina? I need to multiply 10 by my 18. We will have 180 flips happening if each of us flips a coin 10 times. Theoretically, how many times will heads be flipped? Lauren? 90. Remember, it's 1 out of 2, right? So half of 180 is 90. So theoretically, if we flip that coin or each of you flips 10 times. That'll be 180 flips. We should get 90 as you individually should get 5 heads, and as a class, we should get 90 heads. So, we're gonna do that experiment in a minute. And tomorrow, we're going to go over the results in our page. But for right now, I want to look at our second page. So we can't go over this part yet because we haven't done our experiment yet. Let's look at our second page. Theoretically, if we roll a die 120 times, how many times should each number be rolled? This is a regular dice. If we're rolling it 120 times, how many times should we roll? Let's say the number 5. How many times would we roll it? Marina? 24. Why 24? By what number? 5. How many numbers are on a dice? You said 5. Right. So how many numbers are on that dice? 5. There's 6 numbers on the dice. We have 6 numbers on the dice. How many times should I roll a 5? I need to take that 120 times I'm rolling it, divide it up by my 6 because each number should have the same theoretical probability. Melanie, 20. Okay, so that 120 times I roll, 20 of those times I'm going to roll 1. 20 I'll roll a 2. 20 times I'll roll a 3. 20 times I'll roll a 4. 20 times the 5 and 20 times the 6. So now, how many students are in our math class? We have 18. If each of you rolls a die 120 times, how many times are we rolling the dice? Bryn. 2,160. Yep. That is a lot of dice rolls. Theoretically, how many times should each number be rolled? When you multiply 20 times 18, yeah. What did you get? Okay. Melanie.
I did 2,160 divided by 18.
Why divided by 18?
Because there are 18 students in the class?
That's not what we need to divide by. How many different numbers are on our dice, Dom? 6. Yeah, so we should divide by 6. Is that what you did, Dom? What did you get? 360. Because we want to divide that 2,160 up by the 6 numbers that we have the opportunity of rolling. Doesn't matter how many students there are. Okay, so we've got the top part for each of our experiments figured out. We are going to do the experiments in class, and tomorrow we're going to go over the results. So if you are at home, you are going to need a dice and a coin to do the experiments, following through, rolling the dice 120 times and making tally marks, counting up how many of each roll we got. Okay. With the coin flips on the first page, you're flipping the coin, putting in how many heads, how many tails, and then we're going to combine it tomorrow for our class, what we're getting. Okay. So if you are watching this at home, I hope you are well. I hope to see you soon. Have a wonderful day.